atmosphere is irradiated by sunlight. At the Earth's surface, the intensity of light is about the half of the intensity at the top of the atmosphere, as the atmosphere absorbs and reflects in outer space a part of the incident light. The surface albedo is its reflecting power. Albedo extreme cases are white, total reflection like ice, and black, total absorption like sea. The presence of aerosol particles in the atmosphere could change the amount of scattered light. Secondary effect is the cooling of the atmosphere. In this presentation, I want to show a didactic exhibit to measure these particular effects of aerosol. The principal component of the exhibit is a plexiglass case, the atmosphere chamber. The air in the case represents Earth atmosphere. In upper side of the case there is a common lamp. This is the lamp that simulates the sunlight. A 12 centimeters fan cools the air near the lamp to protect the plexiglass case by overheating. In the bottom part of plexiglass case there are two panels to change the albedo. To uplift the panels, two ropes are rolled up around a reel of thread by an electric motor and a gearbox reduction system. The lift system is commanded by a computer. This computer is connected with an Arduino development board. To uplift the panel, I type a letter on a keyboard. The panels are going up. Now I can rotate the panels. The albedo panels before were black. Now they are white. To produce the aerosol, there is a combustion chamber below the floor of the plexiglass case. The combustion chamber is made by an hydraulic T-adapter. The horizontal connection is utilized to fill fuel. The top connection is connected by two straight pipes to atmosphere chamber. These two pipes are the chimney to introduce the aerosol in the atmosphere chamber. The adapter has been drilled down left to connect a pipe to pump air into the combustion chamber. The external end of this pipe is connected with the little fan. It is possible to switch on and off this fan with this switch. To fill fuel, I unscrew the horizontal connector. Little piece of paper can be introduced in the combustion chamber. A match is used to ignite the fire. And now it is visible the aerosol that entering in the case. Switching off the fan, the combustion is stopped, as you can see. Around the horizontal pipe of chimney, there are 4 flexible copper pipes to cool the smoke. In these pipes flows pumped cool water taken from a glass jar provided with the submersible pump. The cooling of the smoke is important to not change the temperature in the plexiglass case. To power all equipment except the lamp, I am using a computer power supply of 350 watt of power. In this exhibit, 5 photodiodes have been used to detect the intensity of light. 2 photodiodes are put at the top of the atmosphere chamber to measure the intensity of light reflected upward. One of them has a UV air cut filter that passes visible light. The filter and its photodiode are put into a black paperboard box to stop exterior light. They simulate 2 sensors put on a satellite looking down the Earth atmosphere. 2 photodiodes are attached on the left and right side of the atmosphere chamber to measure the light scattered by 90 degrees relative to the line of propagation of the light. Due to the large angle of view of the photodiode, it is necessary to put a black paperboard tube to reduce the acceptance angle. One photodiode is attached with hot glue on the bottom of the atmosphere chamber to see direct light. It simulates a sensor put on the Earth's surface. The integrated circuit sensor LM35 is used to measure the temperature of the atmosphere chamber. A digital sensor RHT01 is used to measure the relative humidity of atmosphere in the chamber. All measures are stored in a computer with a simple data acquisition system. Measures are acquired in the Arduino microcontroller board. Then data are sent to the computer. The same Arduino board controls the motor of moving system of albedo panels. The acquisition of data has taken about 3 hours time. Measures of light acquired by left and right photodiodes increase when the aerosol is introduced into the atmosphere chamber. In fact, the aerosol particles interact with the light, scattering towards these photodiodes. When the aerosol is introduced into the atmosphere chamber, the top photodiodes measure an increment of light intensity. The bottom photodiode measures a decrease of light intensity, and the LM35 thermometer measures a decrease of temperature. These results may explain the aerosol effect in the Earth atmosphere. The reduction of Earth's surface intensity of sunlight and the lower temperature of the atmosphere, in opposition to the greenhouse effect. The exhibit is useful for a didactic purpose. It could be either a good incentive to study physics in a secondary school, or a representation of some physics principles in a scientific museum.